to see this tradition continued. And in the series of ACC Concrete Club Knowledge Series, today we have say one more say knowledge evening, and I look forward to a lot of deliberation, a lot of participation, and say learning. And I don't want to take much of your time. Thank you so much for being here, and expecting continued support and patronage. Thank you so much.
Thank you so much, Sunil sir, for your kind words. And I would like to now request Professor Mondal to introduce our speaker and take the journey forward. Professor Mondal.
Thank you, Santanu. It's a great pleasure for me to extend you a warm welcome for today's webinar on advances in waterproofing materials and systems, jointly organized by ICI Kolkata and ACC Limited. I also like to extend a special welcome to our speaker, Dr. A.K. Chatterjee. I think he is a very well-known person. I'm just read out his brief about him. Dr. Anjan Kumar Chatterjee is an internationally reputed materials and process consultant in the field of cement and concrete. He retired from ACC Limited as its full-time director in 2001, and thereafter took up the assignment of establishing Dr. Fixit Institute of Structural Protection and Rehabilitation as an independent knowledge center under the Pidilite Group of Industries, Mumbai. Concurrently, he set up his own consulting outfit, Polymer Technologies Private Limited in Kolkata. In his earlier professional career, prior to joining ACC, he held the position of General Manager with Cement Research Institute of India, now known as National Council of Cement and Building Materials, New Delhi, and Assistant Professor of Material Science in Indian Institute of Technology, Kharagpur. He has also served as a cement expert with UNIDO for assignment in China and Nigeria. Dr. Chatterjee is an alumnus of Presidency College, now a university in Kolkata. Academically, he is a material scientist with a doctoral degree from Moscow State University, Russia, and carried out extensive research work in Bykov Institute of Metallurgy in Moscow and Building Research Establishment in UK. He is a fellow of Indian National Academy of Engineering, Indian Concrete Institute, and Indian Institute of Ceramics. He is an editorial. He is on the editorial boards of Cement and Concrete Research Journal published by Elsevier and Cement Wapno Beton Journal published from Poland. Dr. Chatterjee has a large number of publications and awards to his credit. And at the last, I want to mention that he has given Lifetime Achievement Award from Indian Concrete Institute also. With this brief introductions, now I request Dr. Chatterjee to give his presentation.
Thank you.
Yes, sir, I'm sharing. It's visible, sir?
Yeah. May I come in now?
Please, sir. Welcome, sir. Thank you so
I'm
much. for being here.
audible to all those who are participating
Absolutely
today?
clear, sir.
Okay. At the very outset, my thanks to Shantanu, who took the initiative of bringing me before all of you today evening. I'm really thankful to him. I am also especially thankful to all the leaders in civil engineering and concrete technology. He took real interest in today's evening talk. Professor Mondal introduced me, and my special thanks. You know, we know each other for decades. With these few words, I thought that I may start off on the subject itself so that I don't hold you up inside this meeting for a long time. The choice of this subject was left to me by Shantanu, and I decided on this as I had seen that in many of your previous webinars, various facets of cement and concrete technology had been covered. I thought that maybe I bring in you know, a kind of a different flavor in today's evening talk. That's how I decided to speak on advances in waterproofing materials and systems. May I have the next one, please? Basically, as we all know that concrete as a material is rather intriguing. You know, what happens that you cannot make concrete without water. At the same time, you cannot live with concrete over its lifetime with water ingress. So this is a kind of a dichotomy of concrete as a material, which is often ignored even at the initial construction stage. With increasing cost in construction and repair, this aspect is a very important aspect according to me. And we have traveled a lot from the traditional waterproofing approaches to today's technology where we are. And I thought I must give you a quick rundown. My talk essentially will be related to materials today, not the design or workmanship or execution part of the waterproofing projects, because that's a really big subject which should be handled on a separate session or differently. If I go back to the traditional approaches in waterproofing, we find that it's almost a 100-year-old practice, nothing new today. But what happened that primarily when we started doing waterproofing of buildings and concrete structures, basically we focused on basement and roofing, as you see in this slide. And these these traditional approaches made use of, next one please, the materials that are really, very traditional, I would say, conventional materials for roofing purposes. For example, brickbat coba, mud fuska, lime concrete, China mosaic tiles. These are some of the things which each one of you in the field of civil engineering, you know even better than I would. And for basement also, the box type construction using essentially the showered stone or PCC or you know, similar kinds of materials that we can think of. With these materials, what happened, you know, that what we ultimately try to do is really to create some of the water barriers. But we certainly do not do the waterproofing as we understand today. In addition to that, what we find that with these kinds of approaches, there is a lack of durability, first of all. And second is that there is a lot of additional dead load on the system itself, the building structure itself. And obviously the repair and maintenance is a big issue. The approaches are essentially very cumbersome and labor intensive. Next one, please. So therefore, progressively what has happened that we have tried to avoid some of these disadvantages of conventional waterproofing, as I mentioned to you. And this has been possible, next one please, with the concept of building envelope. And concept of building envelope is that you don't really consider individual elements of the structure for waterproofing purposes. All that you do is you consider the entire structure as a whole, and you try to really take care of the substructure and superstructure, or below grade and superstructure, and also all the joints, flashes, seams, etc. So you take a holistic view of the entire building envelope. And here it's not only preventing water infiltration, but you also try to do the controlling of the water vapor transmission, heat and airflow in and out of the interior spaces, providing a shield against ultraviolet rays or excessive sun rays. And obviously, structural integrity is a very important part of the entire building envelope. And you also take care about the necessary aesthetics in your construction and in your structure. That's how you look at the building envelope as a whole. Next one, please. And just to refresh your mind, all of you know this, that basically we talk about the two systems, the waterproofing systems and the dam proofing systems. The intrinsic difference between these two is that we are talking about the hydrostatic pressure of water, and then the system that protects us from that is the waterproofing. When there is no hydrostatic pressure, but you resist the passage of water, we talk about the dam proofing. I specifically brought in this today because sometimes we use these two as synonymous and sometimes very loosely. And in fact, I see one ad also these days where, the two persons are talking. One is talking about the dam proofing and the other person is talking about the waterproofing. But both are talking in terms of the dam proofing material. So to that extent, we need to differentiate between these two. Next one, please. Other, basic thing to which I would draw your attention for understanding the rest of the things. That's about the positive side waterproofing and the negative side waterproofing. As you see from this slide, on the hydrostatic pressure side, if you are really putting the barrier between the source of water and the interior of the building, that's the positive side. And when you are doing interior barrier and your concrete and the source of water on the other side, we talk about the negative side of building. By and large, for all practical purposes, when we are talking about the basement or roof or anything, we are talking about the positive side waterproofing essentially, although the negative side is also has to be considered for the basement part of it, where really the walling is inside the ground, and there is no other way of doing the positive side. Next one, please. I mentioned to you about the total systemic approach towards the waterproofing. So for all practical purposes, we really break it down into these kinds of elements that we are talking about: the basement, the ground floor, the upper floor, the external walls, internal weight areas, and roofs and terraces. Why I mention this? Because each of these, constructions or elements of the construction has its own characteristics and has its own demands for waterproofing. For example, when we are talking about the basement, there is, significant external hydrostatic pressure. When we are talking about, say, external wall, we are talking about the water permeation through joints and cracks. When we are talking about the internal weight areas, we are talking about almost all the time the water being present in the system. Roofs and terraces, it's not only the water, but sun, wind have their own effects and own problems. So therefore, it's not really one shoe fitting everyone everywhere. You have to really think about, different treatments, different materials. You will have to observe the demands of that structure, building component, and accordingly proceed for the waterproofing. But ultimately, you will have to bear in mind that you looking at the total system in a holistic manner and not just part or the component of the system. Next one, please. With these, initial words, I thought I'll just now say a few things about the modern waterproofing materials and systems. It's simply mind-boggling. Let me start off mentioning about that. Let me start with the first one. Next one, please. Let's talk about the preformed sheet membranes, because this has been, again, a conventional approach to, particularly for the roof waterproofing, or even for that matter, even in the basement. And what we started off with the hot applied built up bitumen and felt membranes, or in other words, the bitumen saturated felt layers were joined also with hot coal tar pitch or with oil derived asphaltic bitumen. So these kinds of systems have been in use for a pretty long time, and it's not that they are not being used even today. But the trend is that from, say, 1990s, as we see that these kinds of systems have lost their popularity, particularly because of the release of the VOCs, or volatile organic chemicals, which cannot be totally avoided in this system. And that's a taboo environmentally. And therefore, the scientific world, the engineering world, the civil engineers, they moved into what we call as the cold applied polymer modified bitumen membranes. Now, what we first try to understand is that the bitumen base was substituted by polymer modified bitumen. Or in other words, we didn't really do away with bitumen in totality, but we did modify the bitumen very significantly by using polymers along with the bitumen. And with this, what happened, you know, that first is the sheets, they became self-adhesive kind of thing. And you really didn't require much of heat in putting them together. You could do the cold application of these membranes, and the net result was that there were improvement in the properties, in the tensile strength, in the chemical resistance of these materials, and progressively, you know, the cold applied polymer bitumen membranes, they have started to replace the hot applied built up bitumen and felt membranes. But still, we didn't really satisfy the environmental demands to the extent it is necessary. So then we looked at the polymer world, and in the polymer world, we differentiate between two. One is the thermoplastic membranes or the thermosetting membranes. The thermoplastic membranes we are talking about, that's roughly, you know, very, for our practical purposes, I can mention that when the heat itself converts this material into a plastic behavior, and that's why we call it the thermoplastic. And the other is that the heat really helps in setting up this, setting the membranes, and that's why we call it the thermosetting. Now, thermoplastic membranes, as we see, say, for example, the glass reinforced PVC that we talk about, you know, is a very good example of this kind of a thing. We talk about a lot of other new materials in this category. Particularly, I thought I would make a mention about the type of materials we are talking about, say chlorinated or chlorosulfonated polymers. We are talking about the thermoplastic polyolefins, which is again polypropylene, ethylene, you know, getting polymerized together into polyolefins. These kinds of materials are there already in the market. They have their specific advantages, and they are in use. And thermoset polymers that we are talking about, you know, basically they're vulcanized rubber systems, primarily, be it natural or synthetic. And we are talking about here what is very, very popularly used by all of you. We are talking about the EPDM, which is basically ethylene propylene diene monomer based. We are talking about butyl, which is a polyisobutylene. And we are talking about even material like neoprene in this category. So as a whole, if you see today that the polymer world has opened up a very large window for waterproofing, while earlier we were more focused on either coal tar pitch or bitumen, asphaltic type. We have now progressively moved towards even non-bituminous systems and total polymeric systems, but they're also complex in their synthesis and making, but they have made a sea change in the environmental demands to be met. Next one, please. But the preformed sheet membrane technology has its own limitations, particularly the vertical application of these materials becomes a big issue, big problem. In fact, blind walls becomes a big problem. So therefore, the further developments that have taken place, they move towards the liquid applied membranes. And liquid applied membranes we are talking about here, we are not really changing the entire concept of chemistry. The chemical concepts that we talked about, either the polymer modified bitumens or even the thermosetting polymers or thermoplastic polymers. In fact, we have added further in the silicone variety to that. We have added polyurea to the entire group of materials. And with that, today, either we can make bituminous binder-based liquid applied membranes or coal tar pitch-based liquid applied membranes. What has emerged, in a very, very savior pattern, I would say, that's the acrylic polymers. And acrylic polymers have opened up a big vista in not only in waterproofing, in many other fields, because here the choice is very wide, and you can really look for doing wonders with this kind of polymers. And these polymers can also be really hybridized with other families. For example, you can make even acrylic urethane, what we call as Puma, or you can also do hybridization of, say, silicone and urethane. And with that, we can make also liquid applied membranes. The other very important development is the polyurea-based systems, not being used much in our country, but yes, elsewhere it is being used, and it has certain specific advantages over even polyurethane. We might talk about that if time permits in a minute or so. Next one, please. The third category, which has added to the entire world of options in waterproofing, what we call as the integral waterproofing materials. And here, it's my reminiscence that my, company ACC was the first in India to introduce integral waterproofing, in a manner of speaking, at the technology level available at that time. And I am taking you back to 1959, when ACC introduced a product called AquaProof, which was basically a lime stearate type of material for integral waterproofing of concrete. You can imagine how far-sighted approach the company had even those days. But I'm very happy to learn now that technologies have improved, the knowledge of chemistry has improved, and today also ACC has come back to integral waterproofing system. I believe what you call as the 202, I think, LB, that's something that is being launched by ACC, I was told.
Yes, sir.
But intrinsically, what I wanted to mention here, that these can be categorized as densifiers, water repellents, and crystalline admixture. And we tend to even, confuse up these three different categories, and we qualify one with the other. The densifiers are basically the approach where you don't try to leave calcium hydroxide as calcium hydroxide in your concrete system. You convert them into densified microstructure of different hydrate systems, which you do otherwise also, for example, with concrete, with supplementary cementitious materials. Water repellents are basically when you use either oil or even long-chain fat-derived materials, and all that you do is you make the material system hydrophobic. That means it doesn't really love water to be near this. And these kinds of water repellents are also available, are being used, but not really that potential from the waterproofing part of it. The crystalline admixture, yes, is a very significant development in integral waterproofing, where all that you do is that you try to grow, you make the material, instead of hydrophobic, you make the material hydrophilic, means you love water. And in the process, the cement and the proprietary chemicals that you make use of together, you really grow crystals inside your concrete element, and you try to really block pores, bridge up the cracks. And today, the technology has come to a level where you can really use this material, which can lie dormant in concrete. And if in the later life of the concrete use, there are cracks, this material can still be brought back to activity, and they bridge up the cracks and continue to keep. But obviously, these kinds of materials are not the single solution for waterproofing under all circumstances, for all types of applications. So therefore, it has its own potential and own limitations. With that, we move to the other system. Next one, please. That's the clay-based waterproofing system. Unfortunately, it's a highly potential area, but least worked upon and least research area, according to me. And here, what we are, practicing in a limited manner, that's the bentonite-based waterproofing systems. And here, either the prefab, panels, right up to trowelable mixtures, all kinds of things based on bentonite composition of clay are available, and they may be made use of. That's known to a certain extent, practiced also to a certain extent, but water being worked upon very intently in some of the research world, that's the asphalt clay emulsions or the rubber clay composites. And these are the kinds of materials which will go a long way in meeting our environmental challenges and environmental demands, and particularly if it is non-bituminous. And that's the kind of a system towards which a lot of work is being carried out, but they haven't really come to much of a practical use. Next one, please. The other part I thought I must quickly go through, that's the joint sealing solutions. And you need not be told, I believe, as civil engineers, that joints are the weakest areas in our structures, unless you have handled them very correctly from the very beginning. And you need right kind of material for right application for solving the problems of joints. And here also we have got plethora of choice. For example, the sealants can be silicone-based, urethane-based, acrylic-based, polysulfide-based. There are many options, and within each, there are multiple options. Particularly, what is being widely used is the polysulfide-based systems. Polysulfide, for the non-chemists here, basically it's a complex chemistry of sulfur and hydrocarbons, and that's the kind of a material which is very much in use. Apart from these, next one please. Apart from these ones, I must quickly take you at least to the title, that polymer modified cement and concrete. Now, this is again a hugely potential area where either you use a latex or redispersible polymer powders or water-soluble polymers, and you can really change the behavior of your cement and concrete, and particularly for the concrete decks, or for that matter, even the concrete wall blocks or swimming pools. These are some of the areas where these kinds of materials will provide a lot of advantages. It's not will provide, they are being used in many circumstances, particularly in the bridge decks and all that. But still, there are many reasons why it is not being used to the extent you need to use them. Next one, please. Let me quickly take you through that specific advances that we have talked about. We have talked about the bitumen modifications. First, we talked about the bitumen to polymer transition that we have talked about. We have talked about the single-ply TPO roofing membranes or thermoplastic polyolefins roofing membranes. We have talked about the latex composition expansion. That's a huge expansion available before the formulators. But what is extremely important is the high performance acrylic polymers, polyurethane versus polyurea, siloxane and silicones, and polysulfide polymers we have talked about. Now, the acrylic polymers today are considered almost synonymous with high performance polymers. And why? Because basically the material can be formulated in numerous ways, and it can be really hybridized with many other materials, and you can really create wonders with the acrylic polymers. Polyurethane and polyurea, basically both are two-component systems, but polyurethane really requires it both are isocyanate based, if you are aware of, but in one case we use polyol along with that. In the other case, we don't use the polyol. And polyurea, as a result of the chemistry itself, is a very rapid setting material. It's resistant to external environment very significantly, and this material is turning out to be a material of choice in many applications. Silane is basically a silica hydrogen link up, as you are aware, and if you have oxygen in that, we are making the material with siloxane, and even silicones are derived, and you make a large number of variants possible with these kinds of materials. Or in other words, today we are in a stage where a huge potential exists from the chemistry and material science, and we can create wonders in waterproofing, particularly that we are talking about, although the opportunities in repair and renewal engineering also for many of these is tremendous. Shantanu, do I have a little more time, and can I cover a few more slides?
Sure, sir. Sure, sir. Please
Sure,
continue,
sure.
sir.
Okay,
Yeah,
Sure.
okay.
please continue.
Let's come to the next one.
Yeah.
Yeah. So since the material choice is extremely wide, so therefore you need to have also the right criteria for selecting the materials. And material properties, particularly the permeability, tensile and elongation properties, resistance against atmospheric and sun exposure, resistance against perforation and laceration, and durability against aging and exposure conditions. To my mind, these 5 material properties are extremely crucial, and they vary from product to product, and we need to look at some of these things properly. But that by itself may not really give you the satisfactory result, because there are substrate conditions which need to be really looked at. And what kind of usage we are going to put this material into is important, and what kind of environment these materials are going to face, that's again very critical. On top of all these things, I think what is very crucial in waterproofing, it's the physical condition and adhesion characteristics of the substrate that we are talking about. Unless that is properly handled and taken care of, many of our good materials can be converted into ill-performing materials. And that's an important area which we need to really look at. Next one, please.
Yes, sir.
Today, for the time that's available, I thought that on the material side, I shouldn't really trouble all the, leading civil engineers with too much of organic chemistry and material science. And I might give you some examples of environmental benefits that we are deriving and can derive more effectively from advanced waterproofing systems. Next one, please. In this context, the first thing I thought I must tell all of you, it's about the urban heat island effect. What is that is known to all of you, that with the kind of urbanization that has taken place globally and also in our country, obviously there is huge concrete construction, pavements, which really absorbs the sun rays and produce quite a bit of heat. In addition to that, the chemicals emitted from the vehicles and factories or industries that add to the problem of urban living. With these things today, the climatic changes are very significant. The moist air and the warm air collision, taking the rains away. These kinds of problems are very much seen. Now, can waterproofing systems be a savior in some of these things? Perhaps to a large extent, yes. Next one, please. This is just the temperature profile of the urban residential system, where you see the temperature profile picking up at the center of the slide. Whereas if you start from the left-hand side, which is essentially rural area, or you go back to the rural farmland, basically the profile today works out somewhat close to the illustration that I have given here. So you need to really tackle the central part, that's the commercial and urban residential area. That's a very important segment that we need to look at. Next one, please. And this, one of the ways in which it is being tackled and can be tackled more significantly, that's the reflective cool roofs. Reflective cool roofs, in the sense, as you see, it's a school building which has got a reflective roof. All that we are telling is that you use the right material for the roof coverage, which gives high solar reflectance. And with that kind of a system, you have also got several other, consequent benefits. For example, if your system is air conditioned, you reduce the air conditioning load in the system. You can also give longer life to the roof itself, because the day-night temperature fluctuations you can substantially reduce with this kind of a cool roof system, and then you derive a lot of benefits from systems of these kinds. And today, as I mentioned to you earlier, that acrylic polymers have opened up new vistas. So the reflective cool roofing, that's one of the tools available with the formulators. You have even the, say, for example, polyurethane fortified, acrylics. That kind of material you can do. The TPOs we have talked about. These are the kinds of materials which have opened up new vistas. In fact, even in our country, aluminum paint over bitumen has also been practiced. Now, this also gives some kind of reflectance, no doubt, but individually, I think that that kind of a system has the deficiency, because we are talking about aluminum, which is energy intensive, and we are talking about the bitumen at the same time. So there are other better alternatives that one can really think about. Next one, please. This is basically the multiple coat, as in any waterproofing system. And in this multiple coats, you have the top coat and the middle coat, and you make the system in such a manner that you have very high solar reflectance from the entire system. Next one, please. By and large, in number of situations, these kinds of different temperature profiles have been really measured. And when you measure these systems in a non-reflective, roof and a reflective roof, in concrete systems, by and large, 7-8 degrees of difference have been observed, particularly at the midday temperature levels that we are talking about. Next one, please. The other system that I must make a mention of in today's talk, that's about the garden roofing. And garden roofing or green roof is another savior for urbanization, according to me. And here there are different varieties possible. And normally we differentiate 3 different types. One we call as the shallow, where the root of the vegetation doesn't go beyond, say, 150 millimeter. And there is a moderate type of vegetation that you can grow, where between 150 to 250 millimeter, this is the kind of a range in which you can go. Or even deep root vegetation you can do, where it's more than 250 millimeter. And this kind of, for example, the next one, if you look at, this is a shallow vegetation roof. Next one, please. Here you can see that it's a deep root vegetation on the rooftop, and this kind of a system is also possible. Now, this is much simple to say than to do. You can imagine that this systemic design and development and execution for green roof is a challenging task that needs to be done in a proper fashion with full understanding of both structural integrity, the materials applied, the system design, and also the execution part of it. Next one, please. For example, this is the green roof, very simplified sketch, where the ACC slab has got a protective screed, and below that you have got the membrane layers, at least 2 layers. Then you have got the drainage board, geotextile sheet, and the soil cover for the vegetation. This is an oversimplified sort of system, but yes, this is also feasible and possible. Next one, please. Whereas an extensive green roof assembly requires a much thought out and well-designed total system, starting from the structural deck to the vegetation. I will not, for the positive time, I will not take you through each of these details, but just to give you an impression that there are materials and it is possible and one can do that. Maybe I would have missed one slide I wanted to mention to you, or maybe it's coming the next one, please. That in India, no, that has gone earlier. Don't go back. I think basically the CII Green Business Center, many of you would have visited in Hyderabad. That's the first green roof project in India. And it was pretty well done by them. I'm talking about almost how many years? Almost maybe 14, 15 years back. And that has been a good system. And I'm sure there are many other examples today available. Let me quickly take you now with these 2 examples to the market size that we are talking about. The global market for waterproofing in 2020 is estimated around $33.5 billion. It's not the material alone, it's the total waterproofing market. And you can imagine it's a very large market globally that we are talking about. And in market size, despite all the problems through which the entire world is moving, it's expected that the CAGR would be somewhere over 5%, and we might come to close to 39 billion US dollars as the market size in 2025. And in this market, the liquid applied membranes are expected to register a faster growth for the advantages of its material characteristics and application advantages that we have talked about a few minutes earlier. I must also mention that polymer modified bitumen products still hold the largest market share in this category of sheet membranes. The green products are steadily gaining popularity over that. And when I talk about the green products, we are talking about the products with low VOCs, and we are talking about the products which will allow recycling of the materials. That's what the future of concrete structures lie in, and we need to recycle, and we should not use certain materials added to concrete which will make the recycling more problematic in future years to come. And as I mentioned to you, there are rising interest in both reflective cool roofs and also the green roof with roof gardens. Next one, please. There are several health and environmental concerns in the waterproofing industry. This cannot be overlooked. These concerns have been there for a pretty long time, for decades, I must say. The concerns arise basically because of the fact that most of the products are derived from petroleum sources. That's why I made a mention that clay-based systems have a potential which you need to really explore progressively. The trouble of health and environment also comes for the bitumen-based membranes, various solvents and dilutants that we make use of. And the problems also come from some of the application technologies. For example, the spraying technology apparently looks very practical and helpful, but has got a lot of environmental implications. The heat-applied systems, particularly torching, also has got its own environmental implications. So those things are being addressed and will be addressed progressively. Next one, please. So therefore, let me not tax you and your patience beyond this level. Already I've spoken for a pretty long time. Basically, all that I'm trying to say is that materials are not enough. Engineering practices, the good engineering practices are essential for the design, selection, and installation of suitable types of waterproofing systems. The durability and effectiveness comes from the right selection, design, and workmanship. The advent of new and improved waterproofing systems and products need to be really focused much more than what we have been doing so far. And finally, there are ternary objectives in waterproofing. One is the effective performance. Second is the environmental protection. And third is the aesthetics. And this ternary objective cannot be lost sight of when we are talking about the waterproofing systems in our civil society. With that, let me thank all of you. I forgot to mention about Shubhajit, my close friend at the very beginning, Professor Saraswati, who is also present today. And it's very nice that he is there today. Many of you I haven't met for a pretty long time. In fact, last 1.5 years, I'm virtually homebound, couldn't really meet up or join physical meetings here and there. Hopefully, we will pass through all this crisis and we will have opportunities of meeting each other more closely and physically. Thank you.
Thank you so much, sir. I think that was an excellent presentation and very exhaustive. And yes, and very rightly, sir, you have said that the material is not enough. The application system is more important. Get the best results. So I'd like to
Thank you,
request
Dr. Chatterjee.
Dr. Mondal to.
Thank you, Dr. Chatterjee. We have a distinguished panelist now. I first take the comments from the panelists, then we will go to the question and answer sessions. At first, I request Professor Saraswati, past president of ICI, to comment on these presentations or any feedback on this.
Okay, thank you, Dr. Chatterjee, for such an excellent presentation. I've been listening to your many presentations over the years, and every time I get totally absorbed in your presentation because the way of your presentation is always excellent. Less to say that. So today's presentation is also extremely useful to the practicing engineers, because you have discussed entire gamut of waterproofing applied to different parts of the buildings. That is very important. And before we start taking questions and comments from different participants, I want to add, which may also require some discussion. That is, look, what happens whenever we are constructing some structure, maybe a small scale, not a. In that case, when we come to the stage of waterproofing, then in many cases our fund is exhausted. Maybe we can take up our waterproofing, etc. maybe 1 or 2 years after gathering some more fund. So during this period, what precaution one can take, that is also a question for small scale construction, if not in case of a large scale construction. So that also, I think, one point need to be discussed. In any case, thank you, sir, for a very nice presentation.
Now I request Professor Devashish Bandyopadhyay, Vice President East of ICI. Please.
First of all, I want to thank Dr. Chatterjee for a nice and lucid presentation. And you are also a very good teacher. Being a teaching community, I can understand that you emphasize mostly on the basics parts, and that will penetrate to the participants in a very deeper way. The material property of nice manner. Little bit that. Hello.
So your voice is breaking.
Particularly
Sir.
when we go for when we go for soil grouting by producing some sort of cement, is there any new technology to improve the water resistance in a particular soil? Structures are subjected to settle due to the erosion of soil below the ground level. Thank you very much.
Dr. Chatterjee, please.
Hello? Hello, over to Sharozda.
Dr. Chatterjee.
Sir, Dr. Chatterjee.
Yeah, Bolun.
Uh,
Please, please.
I think, sir, Professor Devashish Bandyopadhyay
Devashish
asked a
Bandyopadhyay
question.
has asked some questions on ground soil improvement.
Yeah. You know, I think, let me quickly respond to two questions. One is Professor Saraswati asked about the small buildings, and there normally the waterproofing is delayed. You know, that's certainly because of the crunch of the fund and all that. There, what kind of precautions one should take? It's in the construction stage itself. The need for the drainage of water is very important in any segment of the building. Until and unless you have ensured during the construction that the water is not allowed to accumulate somewhere, you will always benefit in terms of the durability of the structure. So that is something that needs to be taken care of. And there are, you know, kind of acrylic emulsion-based coatings that are now available widely all over the world, in our country as well. So those kinds of materials can also come to some saving for the small structures. The other point that, you know, Professor Devashish has mentioned about, that's about the soil grouting part of it. Yes, that's again an important area. And possibly, I'm not an expert in that, but I for one believe that I talked about the integral waterproofing compounds, which are these days technologically much advanced, and those kinds of materials can be used in the soil grouting to take care of the problems locally.
Yes, sir.
Thank you.
What you mentioned, absolutely correct. Even in a particular, if we consider out some housing complex, etc., whether we have carried out the proper waterproofing or not, the drainage is important. In the sense, sometimes we find lack of maintenance, even the groundwater pipes are choked. And also due to some overhead reservoirs, water is overflowing from the reservoir and creating stagnation of water. So if we properly look after issues, if there is no stagnation of water for a long period on the roof, that somehow solves a little bit of the problem, or to some extent, may not be to the full, but to some extent. Yeah.
Thank you. Now I request Dr. Solanki, Vice President R&D Construction Chemical ACC Limited, to give his note on these presentations or any comment on this presentation.
Yeah, thank you, Dr. Mandal. I think it was really a very, very nice and refreshing presentation by Dr. Chatterjee. And if you look, means how effectively he have mentioned means the traditional practices and the modern practices, and there are different materials are available. I think this is a need of the hour, because waterproofing is really a need of the hour, and there are different kind of technology systems available, but people doesn't know what to use, where to use, and how to use. So I think on the material side, I found this was a very, very nice and crisp presentation, which was talking about different kind of material and what are the uses and what are the selection criteria, means how to select something for which in the need. And in the similar line, I think on this, I think the discussion which we had on the waterproofing side, I also would like to say, I mean, what as ACC as a company or at Lafarge Holcim, what we are doing is means in the line. I think when where Dr. Chatterjee shared one instance that when we launched in 1959, the innovation was in focus. And I think in few years back, again, we increased our focus on innovation. And now you see most of the cement which we are bringing in the market, we have something new in that. In concrete, if you look into this, there is something new valued product addition year on year, which are sustainable and have some kind of addition which will suit consumer demand, as well as to add on to this waterproofing range or a construction chemical or building material. We are focusing there as well. And we are bringing in some solutions which are easy to use, more consumer friendly, and suitable to different local need. And the technical service team and we are also aligning to develop the knowledge, know-how among these guys. And that's what we are working. And thanks to ICI and Dr. Chatterjee for the nice presentation. Thank you.
Thank you.
Thank you, Dr. Solanki. I just make a note from Dr. Chatterjee regarding the new application of bacteria, which is nowadays used in your for waterproofing also. I know, Professor, I think you have also known that Professor N.D. Bailey has done a lot of work on this.
Yes.
So can you please comment on that? What is the future of this bacterial concrete or bacteria-based material? On
I
waterproofing
think,
systems?
Professor, if you ask me personally, I believe that it should have much, larger potential than what's happening. There are a few pockets of excellence in the bacteria used in cement technology or in concrete technology. Whereas the possibility of self-healing of concrete with these kinds of technology is immense. And it appears to me that it can be made cost-effective as well. And I do not know why in real practical world we are not really moving towards this kind of a technology. And I remember your work with Bokresher, thermal spring source and all that. I think it was an excellent work, but I do not know whether you could really take it forward and make it for practical applications here and there.
Thank you, Dr. Chatterjee. Now I am handing over to Santanu for taking the comments from the participants.
Right. Thank you, Professor Mondal, for wrapping up so nicely. So, sir, Dr. Chatterjee, there are certain questions that have been posted in the chat box. So I'll ask some of them. I'll just take some of them. So request if you can answer, sir. Yeah. So one question is that whether carbon wrapping system can be used to increase the strength of frame structured building. That is a question to, I think, not on waterproofing.
That's not on waterproofing, but carbon wrapping. I think for rehabilitation and all that, that's a very important technology, no doubt. And in some of the cities, particularly in Bombay, I know of, where a lot of practical application of.
Yes, sir. Hello. Sir, you are not audible.
Maybe a connection issue. Yes, I think what Dr. Chakravarti was about to mention was, now it is.
Yeah.
Now it is audible. Yeah.
Hello.
Yes.
Sir. Actually,
I'm able to hear.
Okay, that's nice, sir. Okay, so there's another question, sir, by Mr. Venugopal C. Is there any equation between design mix and waterproofing systems for a roof structure?
Any design mix is supposed to really look towards the lowest porosity level. And that is where the relationship comes. because higher the porosity, the problem of water infiltration and ingress is always high. So I for one believe that the concrete design system and waterproofing, they have to go hand in hand, and depending on the situation, environment, application, that needs to be really taken care of.
Absolutely. It should be a denser concrete, right, sir?
Yeah.
So the another question, I think a very simple one. Mr. Shunil Kumar is asking that do you have any solution for water seepage? Stop the crack. I think he's asking that whether do you have any solution to stop the seepage from a crack which has developed on the roof?
Yeah, there is no such one word solution
Yes,
to this, because one has to really look at what exactly has happened, what is the reason for the cracking that has taken place. You can always close a crack. There are many crack sealing materials available today. But the question is that if the crack reappears after closing, then your purpose is not served. So this requires a kind of an proper investigation and then a solution found out.
right, sir. Absolutely. There's another question by Mr. Amarendra Singh. After doing application waterproofing over any RCC roof, is it possible to construct new building or tiling over that flooring? And over that waterproofing, can he do tiling? I think that is the question.
But then why do you have the waterproofing at all? I'm not able to understand, because, waterproofing is to prevent the ingress of water. And if you are putting in tiles over that, does he mean that the waterproofing was ineffective and therefore the tiles are being placed?
After doing the waterproofing, is it possible to? No, I think whether it is possible. He's asking whether it is possible or not to do tiling. Maybe he has already done the waterproofing work and now he decides to do a tiling for decorative purpose. So is it possible or not?
No, I think Shantanu, it is about having another floor. I think maybe.
Okay,
so let's save some.
No, he's telling about tiling also, no, new building or tiling.
Yeah. I think it's very difficult. I don't know. I wouldn't like to venture an answer straight away on that, because waterproofing, if it has been properly done and the purpose for waterproofing was something to stop water leakage, so then why should I really look for tiling over that? So I'm not very clear about the question itself.
Right, sir. Another question is, what is the difference between a plasticizer and a waterproof?
Oh, the difference is very large. The plasticizer is basically to plasticize the fresh concrete part of it. So that by itself is not a waterproofing step. And waterproofing is totally different from plasticizing. Waterproofing is for blocking the water, whereas plasticizing is more for workability of the concrete. So there is a big difference between these two.
Absolutely. Mr. Arjit Karmakar is asking, sir, what type of waterproofing material we can use in water tanks and underground water reservoir?
Yeah, basically, as I mentioned to you, that basically it's the silicone-based materials that are being used and preferred in the water tanks. And there are quite a few varieties available today, and one can really see the situation and take a decision which one to use.
There is a question, basically it's on cement. Please specify the chemical formula water repellent admixture which is recently adding to make water repellent blended cements.
There are many. I cannot just give out a specific, additive name. That will not be proper for me. But there are many. As I mentioned to you, there are certain oils which are available. there are some long chain fatty materials which are available. So there are plenty of options there which one can pick up for improved water repellency of cement.
Right, sir. Mr. Sandeep Naik, thank you, Dr. Anuradh Chatterjee, for meaningful information on waterproofing materials, including trends in the market. Thank you, thank you. Please specify green product in case of waterproofing, sir. Green products as a waterproofing
Green
material.
product.
Yeah.
That's what I mentioned, that today the products which are low volatile organic chemicals containing materials and which post demolition can be recycled very easily. These are the two basic criteria which we always consider for the green products in waterproofing. And today there are many, particularly the acrylic based many materials. They are ultimately classified as green products today.
Right, sir. So the questions are continuously coming. So should I take some more, or will just
No.
compile together? And
I think you are the host for this meeting, so it all depends on.
Maybe Shantanu, I think you take 5 random questions.
That's good, I think. Otherwise, I'll take all the questions together and send it to sir. And
Yeah. You can always send it to me, and I can always send you a mail.
Sure, sir.
If there are some, proper replies that I can think of.
The last question, sir, will take. The last question. It is: what is the quality measure to be taken before application of waterproofing based on each system, bitumen sheet and liquid-based system?
Yeah, that what I gave. One of the slides, I mentioned the criteria for selection of the materials. So in the set of slides that are there with you, there is one slide which is on the selection criteria of the materials that can be forwarded to him. They are the 5 different parameters which are important for selection.
Right, sir. Right, sir. I'll do that. And the last one is, sir, the active and passive waterproofing, which one to select? What is the guideline?
Yeah, as I said that, what we call, we don't use the word active and passive. We use the word as the positive side and the negative side. Now, the positive side is what is really desirable in most of the situations, because that prevents the water flow under hydrostatic pressure. Whereas the negative side waterproofing is essentially meant for passage of water where there is no hydrostatic pressure. So the negative side waterproofing is more remedial in nature, whereas the positive side waterproofing is the primary requirement for waterproofing.
Right, sir. Thank you so much, sir. And there are several other questions and there are several praises. Very good presentation from Dr. Chatterjee. Very informative, very refreshing session. Excellent presentation. And all these things are there, sir. I'll send you all the questions and everything in the chat.
Please do that. Please do that.
So now I'll request Dr. Deepesh Majumdar to give the vote of thanks and say a few words, concluding remarks.
Thank you, Dr. Chatterjee, and being a very young teacher of Jadavpur University. Apart from your all technical details, I was just really amazed how we should teach to young people, and that is a really admirable to your speaking power. And we are really lost every connection to everybody. We are your overall speaking power and overall choice of word and how you delivered the lecture. It was a great. Thank you, sir. Thank you. And it was really for a teacher like us. We learned a lot, and you have from very beginning. actually you have learned us that whenever we teach a subject related to repair rehabilitation, we primarily we say word that you please try to any repair strategy, you have to go for try to treat the cause of any distress. So from that cause level, you have to first realize the cause of distress, then you have to repair. So that you have demonstrated and you have explained in a very lucid manner. Thank you, sir. Thank you. And I am really thankful to Shantanu Da, our Shantanu Adhikari from ACC. And I am thankful to Dr. Swaraj Mondol and Dr. Subhajit Saraswati, Dr. Devashish Bandyopadhyay, Dr. Parag Solanki, Mr. Bhatt, and hopefully we'll again meet, sir, under your guidance. And thank you all of you. Thank you.
Thank you. Thanks a lot.
Shantanu Da?
Thank you.
Thank you.
Thank you so much. Thank you.
Thank
Thank you, Dr. Chatterjee. It was an excellent session.
Thank you, Dr. Chatterjee.
And in
Thank
coming
you.
times, we'd like to have a similar session. So thank you.
Sure.
For us.
Thank
Thank you. Thank you. Thank you so much.
you.
Good night,
Okay.
everyone. Stay
Okay.
safe.
Good night.
Good night.
And thank you all the participants also. There's a large participants.
Absolutely.
Thank you, sir. Thank you, sir.